Hi dear students, today we'll discuss about heterocyclic compounds. As you all know, this is one of the very important chapter in organic chemistry part of the BSc 5th Sem chemistry. So it carries about 8 to 10 marks in your exam also. So that's why it's one of the very important chapters in your syllabus. So it is there in all university syllabus for BSc final year students. So we'll discuss it right now. So, as you all see, heterocyclic compounds. The name heterocyclic includes two words. The first word is hetero, which is a Greek word from heteros, which means different, which means different. And the another word, cyclic, that means ring structures. That means ring structures. Usually in organic chemistry, we see the rings like benzene ring, where we can see that all the ring atoms here are the carbon atoms. So in this case, if one of the carbon atom in the ring, if it is replaced by any other element other than the carbon, for example, I am going to replace this carbon with nitrogen. So such compounds, this compound now become a heterocyclic compound. So I have just replaced a carbon in benzene, and with the nitrogen, that becomes an heterocyclic compound. For example, this is benzene and its name is pyridine. It is one of the very important heterocyclic compound. As we have seen, it is used as a organic solvent. So now using these terms, we can now define the heterocyclic compounds. So if I write the definition of heterocyclic compound, please see here. The cyclic organic compounds where one or more carbon atoms in the ring, that you should remember, not outside the ring, in the ring has been replaced by heteroatom, replaced by a heteroatom. So such compounds are known as heterocyclic compound, are known as heterocyclic compounds. This is the definition of heterocyclic compounds. The definition says the cyclic organic compounds where one or more carbon atoms are replaced by the heteroatoms. So here you can see heteroatom is the nitrogen. The most common heteroatoms we find in heterocyclic compounds are nitrogen, oxygen, sulfur. And in few compounds we can also see phosphorus, boron, silicon, etc. So these three are very important. The heterocyclic compounds containing nitrogen, oxygen, sulfur. We are going to discuss those compounds in this chapter. And to discuss before the heterocyclic compounds, we must know the scope of the compound. Why should we study this? because these are involved in our daily life, even in our life. Okay, so if you see its biological role, actually its chemical role is so much high now, because these are heavily used in our chemotherapeutic agents, dyes, and also polymers, copolymer. They have used as copolymers. But in biologically also they have been naturally involved in our system. So for example, it is also present in DNA. All adenine, guanine, thymine, cytosine, the uracil, those all are containing heterocyclic compounds, our nitrogenous bases. In DNA, also in RNA, in heme, hemoglobin, heme, and also in chlorophyll in plants. Okay, these all have been in a very important chapter that we are going to study in the next next chapter, that is our alkaloids. That is also usually there for final year students. We can see there the heterocyclic compounds. So that's why we should study this compound in detail. If you see some synthetic polymer, synthetic heterocyclic compounds, the synthetic heterocyclic compounds are also used as chemotherapeutic agents, that is we commonly known as drugs, and copolymers, and also dyes, where we can see the synthetic heterocyclic compounds are also being used. These are naturally heterocyclic compounds found in this RNA, DNA, and etc. Now we have the application of these heterocyclic compounds even in these industrial things.